Okay, then this is a video that looks at the groups in the periodic table. So let's start with a little sketch just to remind ourselves. So there's a sketch of the periodic table, and within the periodic table we have got this group here. Remember, groups go up and down, and this group here are group 1 in the periodic table, and they are called the Alkali Metals. Okay, so group 1 over here, we've got the Alkali Metals. We've also got in the periodic table a group over here, and this is group 7. And group 7 over here are known as the halogens. And then the final group over here, this group over here, are known as the noble gases, and that is group 0. So in the periodic table, we've got other groups that are important, but these are the 3 key ones that we're going to be concerned with. In the first part of this video, I'm going to look at group 1, the alkali metals. Let's just remind ourselves, we have got lithium, sodium, and potassium are the first 3 elements in that group. Now lithium has got 3 electrons, so a little review of the electron configuration. 3 electrons means you have 2, 1. So the arrangement is 2 electrons in the first, 1 in the second. Sodium has got 11, so that means it has 2, 8, 1. And potassium has 19, so that becomes 2, 8, 8, 1. So you can see from this, they're all in group 1, and they're all in group 1 because they have got 1 electron in their outer energy level. And that means that during a chemical reaction, these all want to lose that outer electron to become stable. So all want to lose 1 electron to become stable. So that's what they're going to try and do when they react. If we think about at the experiment you will have seen when we showed you in class, that we take each of these metals and we add them to water, and when we put them into water, we're looking for patterns in the way they react. Now before we put them into water, we will have put them onto a little white tile, and during that process we will have cut them into smaller pieces. So if we can cut this into a smaller piece, what does that tell me about this metal? It tells me that these metals are very soft. We can actually cut them with a knife. So they're soft because we can cut them with a knife. We then, as part of this experiment, we put them into a big trough of water, and this metal floats on top of the water. So the fact that it floats tells me that it has a low density. So it's floating on top of the water, it's got a low density. Now once it's on the water, mid contact with the water, that is when the reaction actually begins. So let's have a look at some of the key things about the reaction with water. So during the reaction with water, what you'll see this doing is it will start to move around. So the metal will actually start to move on the surface of the water. And as it starts to move around, you will hear it fizzing. So it starts to fizz. It's fizzing because it's producing a gas. So it's starting to fizz, producing a gas. We're able to then collect that gas and test that gas. And the test that we do is the lighted splint test. So we can collect the gas, put a lighted splint inside it, and it burns with a squeaky pop. And if you remember what that means that this gas that is being produced is hydrogen. It also, if you look very carefully as it's starting to move around, the structure of the metal starts to change, and it actually starts to form a molten ball. So where you had sharp edges from where it's cut, it now starts to become nice and smooth. Why does that happen? Well, it happens because this reaction is producing heat, and that means an exothermic reaction, so it's producing heat. And the heat from this reaction is enough to make this metal melt and become molten and form a spherical shape. So the fact there's enough energy in this reaction to make it melt and become molten, this has a low melting point. You'll also notice that if you have potassium in this situation, so you put potassium in here, then it will burn with a lilac flame. So you will actually get a little lilac flame on top of the metal. And what's happening there is the metal is reacting with the water. This metal is then producing the hydrogen, and there's enough energy in this process to cause the hydrogen to ignite, and the hydrogen is actually burning with a lilac flame. Now, when we did this in class, we added universal indicator to this water, and initially water is neutral, so it turns green, but over the course of the reaction, the indicator started to turn purple. So this indicator goes purple. Remember that purple means that there is an alkali present. So an alkali is being produced in this process. And remember at the very beginning of all this, we said that these are the alkali metals. So this reaction is producing the hydrogen gas, an alkali. The indicator is showing it's an alkali, it's going purple. So it's producing two products, and that's why these are called the alkali metals. Let's have a little bit more of a look at the reaction with water. So I'm going to just swap my sheet over. So this reaction with water, then what we've got here is as you go down the groups, we've got our lithium, sodium and potassium. As we go down this group, lithium, sodium, potassium, then the reaction actually starts to become more violent. Okay, so as you go down this group, they are becoming more reactive. And we need to be able to explain why that is, and we'll do that in a second. Before we do, let's go back and just remind ourselves what this reaction is doing and how we construct a word equation from this. So this reaction, we are taking a metal, a group 1 metal, we're adding it to water, and we said it was making an alkali. Remember, the water goes purple, so it's making an alkali, which is a metal hydroxide, and it's also producing hydrogen, okay, which was the gas that burned with the squeaky pot. So in this process, when it's doing this, let's use sodium as an example. Here's my sodium, and we're going to add it to the water. All we've got to do is say this makes a hydroxide, which is the alkali, so that is going to make sodium hydroxide plus the hydrogen that's causing the squeaky pop. In symbols, you need to be able to balance this equation, so it's sodium, Na, water is H2O, sodium hydroxide, remember sodium is a positive ion, Na plus, hydroxide is OH minus, so we need one of each of those to make it work, and then we have got H2, hydrogen's diatomic. If you check, 2 hydrogens on this side, there's 1, 2, 3 hydrogens on this side, so we need to do something here. Easiest thing to do is this is 3, is try and make this become an even number. So if I put a 2 in front, that gives me 2 hydrogens, and 2 hydrogens there gives me 4. So I can make 4 on this side by doing that, gives me 4 hydrogens. That gives me 2 oxygens, so the oxygens are balanced, the hydrogens are balanced, 2 sodiums, only 1 here. Put a 2 there, it gives me 2 sodiums. So we've got a balanced equation. My advice to you is to try this now yourselves for lithium and then potassium, using the general equation to help you construct what it's going to do, and then produce the balanced equation as well as part of that. Let's come back to this pattern in reactivity, because we've said that as you go down the group, these metals become more reactive, the reaction becomes more violent. So why is that the case? Well, if you go back to where we started, with lithium having 3 electrons, 2, 1, and this is the nucleus, the little positive nucleus to the atom, and sodium was 11 electrons, so it's 2, 8, 1, and there's the positive, and potassium is 2, 8, 8, 1, and that's positive as well. And if you remember at the beginning, we said that what they're trying to do is lose this electron, so trying to get rid of that electron during a reaction. And you can notice that the distance that electron is from the nucleus is actually starting to get bigger. So there's the distance this outer electron is from the nucleus in lithium. The distance in sodium has got a little bit bigger, and the distance in potassium has increased again. So the attraction between the positive nucleus and the negative electron is going to be getting less and less as the distance starts to increase. Okay, so the first one we can look at here is that the attraction between the positive nucleus and negative electron decreases. Why does it decrease? Because the distance is increasing. So this happens because the distance between the nucleus and outer electron is increasing. And if that distance increases, then it's going to be easier to lose this outer electron. So this is quite close, it's quite hard to lose it. This has got a little bit further away, therefore it's easier to lose this electron. And this has got even further away, therefore it's easier to lose this electron. So as this distance increases, it's easier to lose the electron, and therefore they become more reactive. Okay? So the final bit, it is easier to lose the electron, so the metal becomes more reactive. So in group 1 in our periodic table, as we go down this group, they become more reactive, and they're more reactive because the distance between the positive nucleus and negative electron is increasing, therefore it's easier to lose this electron, therefore because it's easy to lose, it's a more reactive metal. Okay, that's the first bit. There's going to be other videos now linking into this. We're going to look at the halogens, as I said, and the noble gases, and that then covers the groups in the periodic table.